So today really we're talking about is different ways to describe sets. So our topic is our topic Common Core. It stands for Algebra, SSE, sets and subsets. And so what we're going to do is interpret expressions in sets and intervals. That's our Common Core. And until President Trump gets rid of the Common Core, we're going to do Common Core, all right? We don't know what's going to happen. So, all right. So interval notation, right? We had a little bit of that, but let's do the set notation. So here's set notation. You start off with this. Just start off with this little, that symbol means set. In mathematics, that little squiggly sign means set. So just write it as squiggly. Now, the variable. What variable do I want to use? I can use any variable, but normally we use x, don't we? So we're going to go to the set of x. You can use n for numbers if you want to, but whatever variable you use, you got to stick with it, okay? So let's give the set x, and we go this little dot dot. So it says, given the set of x such that. Well, let's look at this. I know I'm going to go from -1 to 4. So I'm going to go -1 is less than or equal to. Equal to because it's a solid dot. X, which is less than 4. And I close the set. So write this down. -1, less than or equal to x, less than 4. Now, if you are me, and I'm looking at this, I said less than or equal, but it really says it's really greater than -1, 0, 1, 2. But if I read the x backwards, it does say x is greater than, doesn't it? If you read the x backwards, it really does say x is greater than or equal to. So when you do set notations, keep this in mind. Always remember this. The Pac-Man symbols always point the same direction. Always. Never have them pointing opposite ways. They're all either always going to point to the right or to the left. Don't have them switch around. They will always point the same direction, okay? And it does say x is less than 4. That makes sense. And I did not put an equal sign here because it doesn't equal to 4. It's an open circle of 4, okay? Thumbs up, sideways, okay? Kind of sideways, thumbs up. Okay, good. Now the easy part, interval notation. This one we like. Bracket, right? Bracket, because it's a solid dot. It includes -1, comma, 4, parentheses. Interval notation. It includes, so bracket means it includes, it's equal to. Parentheses means it doesn't equal to 4. Easy? Thumbs up? Okay, good. Example 2. So first of all, describe the set in interval notation and draw a number line. Okay, -3, less than x, less than or equal to 1. So let's do the number line first. I think it's easier to do the number line first. So we'll put a -3, we'll put a 1, and I'll put a 0 in there. I don't care if you put in every single number. You can. I just need the important numbers, okay? You do not need to put all the numbers in between, okay? I just need the important ones, okay? So when I look at this, first of all, I notice that what I want is it is greater. If I read x backwards, it's greater than 3, but it doesn't equal it. So I'm going to put an open circle at -3. There's no little equal sign. And if I read x backwards, it is greater than. So it goes and shades this way. But it's less than or equal to 1. But it does equal 1, so I put a solid dot. Less than goes this way. So it's everything in between -3 and 1. Okay. Now, if we wanted to put that in interval notation, that's pretty easy. I'm just going to go parentheses, because it does not include -3, comma, 1, bracket, right? It includes 1, so I use a bracket. Does not include 3, open circle, so I put up parentheses. Thumbs up? Okay, good. Now, number 3 is a little tricky, and that's why I put it on here. I want to make sure we take a look at it. But let's do set notation first, okay? So I've got two things, right? I've got this, and I've got this. So what we're going to do is we're going to put an or in between, okay? We're going to say our answers are either here or our answers are here, okay? We've got two things here. We've got either answers here or answers here. So in set notation, again, we'll go this little squiggly set symbol, okay? Set notation, write your little set symbol. What variable do you want to use? X. Given the set X, such that, okay? There it is. Such that, well, what do we got? We've got -4 is less than x, which is less than negative 1. I did not put little equal signs. There's no little equal signs because it's an open circle. It does not equal negative 4. It does not equal negative 1. So there's no little equal signs. Okay, then I'm going to go or. Because I've taken care of this shading in this set notation. I've described this shading, but now I have to jump over and describe this one. So this one is going to start at 3 and go to infinity, right? So we're just going to say or x is greater than or equal to 3. Now that would keep going. Greater than or equal to 3, that states it's going from 3 to 4 to 5 to 6 to 7 to 100 to a million to a zillion. No such word as a zillion, by the way. Gazillion, no such word as gazillion. But you got the idea, all the way till the end, which is at infinity. Which, by the way, you can't get to infinity, can you? Interval notation. What do you think? Interval notation. How can we describe this in interval notation? Now we're going to take two parts. We need two parts, right? Does it include negative 4? Is negative 4 an answer? No. Parentheses. Negative 4, comma, right? Does it include negative 1? Is negative 1 an answer? No. Negative 1, parentheses. Now we're going to go or. Does it include 3? Yeah, it's a solid dot, so we go bracket 3, comma. Now what's going to go at the end here? How far does this arrow go? Infinity. It goes to infinity, right? That's the very last number. By the way, infinity is not a number. It's not a number. So do I use a bracket or a parentheses here? Can you ever get to infinity? No. If you could get there, you could put a solid dot, but can you ever get to infinity? Can't get there. Parentheses. You can never get to infinity. Infinity is not a number. I played one of those brain games the other day because I like these little brain games, and one of the questions was infinity. It says, what's the largest number? And they put down infinity. I'm like, no, they're wrong. But so I'm going to write the company and say, by the way, you make a brain game. You're not smart enough to know that infinity is not a number. But anyway, that's my thing. Anyway, moving on, huh? Okay, describe the ages in this classroom in roster notation. Okay, so let's see. Is anybody, you got to be honest, anybody 14? Anybody younger than 14? Okay, so we got 14, right? So let's go 14. 15? Oh, yeah, we lost people 15. Anybody 16? All right. 17? Okay. 18? Okay. And yes, there is somebody in here, 56. How sad. That's our roster notation. Okay, on a number line. And I'm probably going to exclude 56 because I can't make my number line long enough, okay? So when I do my number line, I'm going to leave out 56 because I'd have to make a really big number line. So my number line, let's just put down our 14, 15, 16, 17, 18. I guess way up here we can put a 56. How's that, huh? No, I put a dot. Single dot. Single dot. Single dot. Single dot. Single dot. And single dot, okay? Now, you could almost argue, I'm going to say you could almost argue that we could fill in we could fill it in, right? Because somebody might be 14 and a half, right? But are you exactly 14 and a half? At this moment? At this moment, are you exactly 14 and a half? Oh, sorry, this won't last. It's gone. Are you exactly 15 today? Is somebody exactly 15 today? Not really, but so if we say just these numbers, then we don't shade in between because we got a 14-year-old, we got a 15-year-old, 16, 17, 18, and we even have a 56-year-old, okay? That is the number line. It's dots, it's not shading, okay? And the only way you can describe that is with roster, right? You have to use a roster. You can't use an interval because there's nothing in between, okay? Thumbs up? Guys, it's pretty easy, isn't it? Okay, ready to turn the page? All right. All right, oh my goodness, it looks like math now. You got this member of and this weird thing. And okay, list the members of this set. Okay, well, let's figure out what's going on. So first, what I want to do is on a number line. So let me draw a number line. Okay, I'm going to draw a number line. Even if I don't have a clue what I'm doing, at least I know I have to draw a number line, right? So let's draw a number line. All right, there's a number line. Okay. Now, let's see. Natural numbers. So do you remember what our natural numbers are? Anybody remember? What are the natural numbers? What are the natural numbers? Anybody remember the number? Yeah, go ahead, Austin.
Counting numbers.
Yeah, the counting numbers. They're really, it's 1, 2, 3, 4, dot, 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 okay? So what are we going to do with these numbers? We're going to plug them in. So if I plug in 1, 2 times 1 is 2. So we'd have a dot at 2. Put in 2, 2 times 2 is 4. Put in 3, 3 times 2 is 6. 4, 4 times 2 is 8. 5 is 10. And I'm getting pretty tired of doing this. I think I got the idea. How about you? You got the idea? But does it continue? It does, doesn't it? So here, how do you think you can show that it continues? Arrow. Let's do this. Let's make this arrow nice and dark. Okay? So if I make a big, fat arrow, it tells me, hey, this pattern just keeps going on and on to infinity, doesn't it? Right? It's an infinite set. Okay, last problem. Almost there. Okay, example 6. All right, so first of all, let's graph this on a number line, okay? -3, 2, and I'll put 0 in there right about there. You don't really need 0, but I'm going to put it in anyway, just for reference. Okay, so let's read x backwards. Okay, if I cover up, let's read x backwards. Okay, see it? Read it. So read it backwards. It says x is less than -3, right? So less than, that'd be like -4, -5, -6. So that's less than. So what I want to do is shade this way, right? Got it? Okay, and this says x is greater than or equal to 2, so I'll put a solid dot at 2. And I'll shade this way, make it a nice dark arrow because it goes on forever now, okay? Alright, so it's really from -3 back and from 2 forward, okay? So it's going to be less than -3 but greater than or equal to 2, okay? So what about interval notation? What about interval notation? Well, I know for sure I'm going to have an or in between because I've got to go from here to here, right? I know for sure I'm going to have an or because I'm going to have whatever I say here, and then I'm going to say, okay, or I'm going to have whatever I say here, okay? All right, so let's do interval notation. Let's think about it. What is the very last number on this number line? What's the very last thing on this number line? If I keep going, where am I going to go to? Negative infinity, right? Can I ever get there? Can I ever get to negative infinity? Parentheses, negative infinity, comma, -3. Now, is -3 included or not? Is -3 included or not?
No.
It's not. Parentheses, right? Or, I got to jump from here to here. Or, okay, I go to 2. Is 2 included or not? It is. So, bracket 2, comma. Okay, what's the very last? Where's this going to? Infinity, right? So infinity. Can you get to infinity? No. Parentheses. There it is. All right, not too bad. So homework today, page 10, 6, 9, 16, 19, 21. My guess you'll probably get this done